f of x equals 7 cos 2x minus 24 sine 2x. Given that f of x equals r cos 2x plus alpha, where r is greater than 0 and alpha lies between 0 and 90 degrees, find the value of r and the value of alpha. Hence solve the equation this equals 12.5 for x between 0 and 180 degrees, giving your answers to one decimal place. Express 14 cos squared minus 48 sine cos in the form a cos plus b sine plus c, where a, b and c are constants to be found. Hence, using your answers to part A and C, determine the maximum value of 14 cos squared minus 48 sine cos. So that's the question there then. Let's have a little look at it then. So part A, we need to find r and alpha first of all, so let's do that. So here, what have we got then? Well, we've got r, and expand this compound angle cos cos, minus sine sine, isn't it? So it's r lots of. And that needs to be made equal to 7 cos minus 24 sine. Now we can read off the correspondences between cosines and sines. So, as far as the cosines are concerned, 7 is r cos alpha. And the r sine alpha then, here, is both the minuses tally, so it's r sine alpha equals 24, isn't it? Okay, so that tells us then, this is equation 1, this is equation 2. This will tell us that tan alpha then is equal to, divide 2 by 1, tan alpha is 24 over 7. And so alpha is equal to shift tan 24 over 7. Let's just tap that in. I've done it here. 73.739. 73.739, which equals 73.7 to the 1 decimal place degrees. There's alpha. R, on the other hand, customarily we square both sides, these terms and this term. And when we add them, we'll get r squared sine squared plus cos squared, which is 1. So we just get r squared on this side. So bear that in mind, this is a square here. And that will equal this squared plus this squared, of course. So I'm going to remove the r squared now, and just square root both sides in this line here. And that's equal to 25. So r is 25 then, alpha is 73.7 to 1 dp. So hence solve fx equals 12.5 for x between 0 to 180. Let's have a look at this then. So here, okay, we can replace f by this value here, r cos 25 cosine at 2x plus the alpha value is equal to 12.5. That tells us then that cosine 2x plus the alpha value, which we know, move the 25 from times to divide, 12.5 over 25 is a half. Okay, now 2x, x goes from 0 to 180, so 2x will go 0 to 360 degrees, won't it? Draw a circle, customarily. Right cast. Cosine is positive here and here, so draw 2 lines. Mark off the alpha associated acute angle to the horizontal and simply write cos alpha equals a half. We know that alpha will be 60 degrees in that case, don't we? Cos of 60 is a half. So our first solution is round to here. So 2x plus the 73.739 is equal to 60 degrees. And also, I'm going to put the 2 answers here. The other solution is right round to here, which is round 360, back 60, so that's 300 degrees. So let's see what that tells us then. So that tells us that 2x is equal to, now, it's going to be 60 minus the 73.7. I'm just going to write it as 73.7 degrees at the moment. But that's a negative angle. We need to bring it into our range, so we need to add a full turn, don't we? This one will be 300 minus the 73.7 degrees. So that tells us then what x is. Okay, basically we've got, this is minus 13.7, 360, so this is 2x. 360 minus 13 is 346.3 degrees. And also this one is 226.3 degrees. Tap them in the calculator if you need to. X is equal to, divide by 2, 173. Point. Now this 3 came about from this 0.3, so it's 0.7, but it was just above 0.7, so this will be just below 0.3. So when you halve it, you'll get 0.1 rather than 0.2. And here this will be 113. 0.1 again, degrees. So there's our solutions then for x in the required range. So that's part B then. So let's have a look at part C. Express this as A cos plus B sine plus C. Okay, I'm going to copy that and drag it. So let's drag that down then. Here it is here. So let's just take it and move it down. Hopefully we've got what we need here. So this is part C now. Okay, so let's have a look at this then. So we've got this, and this can be written as 7 times 2 cos squared x, and 2 cos squared x, well, if you remember sine squared, cos 2x is cos squared minus sine squared. So cos 2x will equal 2 cos squared minus 1, isn't it? So the 2 cos squared, which we can pull out of here, will be cos 2x plus 1. Good. So that's that, just a little memory thing there. Okay, so what else have we got? We've got a 2 sine x cos x here as well, so it's minus 24 sine 2x, isn't it, that we can put there. So what have we got? It's going to be 7 cosine, when we expand the bracket, 2x minus 24 sine 2x plus, and then expand the bracket, we get a 7. So we've got our A, B and C then, haven't we, here. Okay, and we found them A cos B sine, so A is 7, B equals, it was plus B, wasn't it? Plus B here, so B is minus 24 and C is 7. Okay, now part D, let's have a look at that. Last part then, using A and C to deduce the maximum value of this. Well, this is equal to, so the answer, the value, sorry, is equal to, what have we got then? So we got this. Now we've just said that this thing here is equal to this. So this can be replaced by, remember this was what we started with in part A. So I'll just flick back up. Here's part A, and that was r cos 2x plus alpha. So here, this is r, which is 25, cosine 2x plus 73.7 degrees plus 7. When is that maximum? That will be less than or equal to, cos varies from 1 to minus 1, so this will go up to the value of 32. So maximum value then is clearly 32.